Good afternoon. Today, the another portion of LPP will start and will discuss on assignment problems. Like previous classes, we have seen transportation problems. Also, we have seen how to solve LPP by different methods. This is one of the important chapter you can say, or you can say the part of this LPP where we are looking how to assign the job to different machine, or how to assign the job to different employees or to levels. When you have more number of jobs and we have a more number of machine, but that too should be finite number of jobs or finite number of machines. So unless it is finite, you cannot assign it. It should be finite. You talk about job, or you talk about machinery, or you talk about employees or labor, it should be finite. So the assignment problem is the part of the transportation problems. As you know, transportation problem also the part of the MPP. So directly or indirectly you can say it's a part of the or subclass of the linear programming problems. Now we'll see as like transportation problems, the terms are using supply, demand, capacity, requirement, availabilities. Like here, there is some of the terms which will be come across like jobs, machines, employees, labors, etc. These are the terms we are going to use frequently. So this is also sometimes you can say job assignment problems. Job assignment problems. And one of the mathematician whose name is Hungarian, who has given ideas how to solve these assignment problems. Right? The mathematician name is Hungarian. So he has created an algorithm, step-by-step procedure how to solve one assignment problems. Also, he has given idea about routing problems. But today we'll see how the assignment problem is solved through step-by-step procedures. Also, we'll see how many types of assignment problem exist. When you are facing the assignment problems, what way it can come. So there are three varieties of assignment problems we have. One is minimization form, and sometimes it can come in maximization form, and sometimes it can come in constraint form. But usually you are considering two ways. One is minimize and second is maximize. As you know, it is the part of the LPP. So LPP having objective. The objective always expressed in the form of what? A minimum Z or max Z. Mean Z or max Z. So the assignment problem can be expressed in both the ways, either in minimum form or in maximum form. Like as I said earlier, you have to think of what will be minimized, what will be maximized. Same thing when the cost given, time given, like the laborer involved with particular jobs, we are looking in the less consumption of time, how they can cover this process. Then you are considering the time part. Here, the objective function is minimum Z. Let you have engaged some salesmen in different districts or different areas. They are involved in selling of any particular product like this. So here we will be expecting the objective function should be maximum. So easily you can identify when the objective function is minimum form or a maximum form. Because the moment if you came to know it is in minimization form, then the procedure will be different. And if it is in maximization form, some additional steps will be used after minimization form. That we'll discuss one by one. And there's another variety that is called constraint form. Now, sometimes what happens when you have let 4 job and you have a 4 machinery or 4 people. Let 4 people you have and 4 job you have. So always the assignment problem says the relation should be 1-1. One job to one labor or one employee. Second job to second employee. Third to third employee. Fourth to fourth. The relation should be 1-1. Like if it is labor number 1, then you have to assign a particular labor 1, then you have to assign one job. Make an assign job 2 or job 3. Let you have a 4 job J1 to J4. You have the labor like L1 to L4. So your objective is how to assign all the jobs to different labors. But the relationship you have to maintain 1-1. One job should be assigned to one labor. The another job you have to assign to another labor. But here the relationship cannot be many one or one many. I mean, one job cannot be assigned at a time to more than one labors. Repetition not allowed. Similarly, one labor should not be involved with more than one job. That always you have to keep in mind. The Hungarian, taking this consideration, he has given ideas how to solve the assignment problems. When you have a 4 job and you have 4 labor, then you are thinking which job should be assigned to whom, by which the total processing time will be minimum. Or you are assigning a job, you are expecting profit, so to whom what job will be assigned, by which the total profit will be maximum. Like if talk another example, like an educational institution, when you have a principal or a head of the department, he is assigning different classes to different faculties. Let he is having 7 subjects and he is having 7 faculties, 7 professors are there. So he has to find out, because all have the essential qualifications, all have the similar qualifications, all can take all the classes, but he has to find out the subject intrinsic difficulties and expertise in that subject. Looking that, he will be assigned the different subject to different faculties. Though all the faculty can take all the classes, but while taking the classes may not be effective. The consumption time or the syllabus coverage they may not do. So there are different factors involved. Looking all these factors, he has to take a final decisions who will be taking which classes. The for this, when you have a 2 variables, you have to keep all this data in the form of matrix. As I have written here, it is a part of the transformation problems. As you know, in transformation problem also we are showing the data or keeping the data in the form of matrix. Here also matrix required. Let me show. There is a need of matrix where you can keep one side machine or one side labor, one side employee, like this you have to keep. Now coming to third point, what it says, always it has a focus to maximize or minimize objective function, which I have told you. Now, as like similar to transpersonal problems, always you should have like some mathematical formulation of each and everything. So in assignment problem also you have a mathematical formulations. Like as it is coming under LPP, and LPP always says you should have a 3 steps. First step is objective function. Second step is subjected to constraint. Third step is non-negative constraint. This is first step. And the second step is STC, subjected to constraint. Third step is NNC, non-negative constraints. Sometimes in some materials it might have written non-negative functions. So because a constraint nothing but a variable. Sometimes variable can be also expressed in the form of functions. Like when you are writing y is equal to fx, here y is a variable, but we are able to define it y is equal to f of x. So y is a function which contains the variable x. So here the objective function, as like the transpersonal problems we have seen in transpersonal problem, you are writing minimum z, but we never write max z y. With the transpersonal problem always says the transpersonal cost will be minimum, because you cannot go for more expenditure. If you go for more expenditure, obviously the profit, it hampers the profitability. You may get less profit or you may get suffering loss. But here in assignment problems, the objective function can be written in both the ways which I have shown in the previous, which I have highlighted in the previous slide. Always the objective function should be either in minimization form or in maximization form. So here in transpersonal problem, you have seen we have taken double summations. Why double summation? Because we are considering matrix in the form of rows and the columns. The one summation for rows, one summation for columns. And for both, we have some lower limit and we have some higher limit. I mean, lower limit and upper limit. In case of transportation problem, we have taken z is equal to summation I is equal to 1 to m summation j is equal to 1 to n. So here the lower limit starting in both the cases is 1, but the upper limit is different. Why? Because in transportation problem we are looking supply demand. Supply demand should be matched. We never consider other factors. If it is mismatched, then you are saying it is unbalanced TP. Then you are trying to convert it to balanced TP by adding dummy row or dummy column with the extra unit you needed. Or you did. Or you are ready. But here the focus is the assignment problems you have to express in the form of matrix. But again, same thing you have to consider, the assignment problems will be balanced. How to be balanced? The matrix should be a square matrix. What is square matrix? The matrix said to be square when the number of rows is equal to number of columns. We are not looking what things are there in the rows or columns. We are looking just number of rows should be equal to the number of columns. Whereas transportation problem says something different. Whatever the order of the matrix may be, doesn't matter, but supply demand should be matched. Like we have seen previously, if this is a transportation of problems, we are looking this side what supply, this side demand. So we always observe the sum of the supply should be equal with sum of the demand, or sum of the availability is equal to sum of the requirement, or sum of the capacity is equal to sum of the requirements. Like this you are considering. And for example, this is 4 cross 3. The number of rows are 4, number of columns are 4, both are unequal, and no need also. But the value you are writing the supply side, like for example 10, 15, 10, 20, the total is 30, 45, 55. So this addition, this side demand should be also 55. Let 5, 30, let 20. Here sum of the supply, sum of the demand is equal to 55. That is a balanced TP. Once balanced TP, then we are finding BFS by using different methods, as I said earlier, northwest corner rule or least cost method or BAM methods. Then we are going for optimal test, where we are trying to optimize the solution which you have got through northwest corner rule, or through BAM method, or through least cost method or matrix method, or through row minimization method, or through column minimization methods. But if you compare these two in the form of objective function in mathematical form, check you can understand it. Here this is Cij, Xij. This is the mathematical form of TP. This is the mathematical form of AP. What is the difference we are getting? The difference is that here both upper limit is ANN, but here upper limits are different. Because in case of transportation problems, we are looking supply demand. We never look the number of rows should be equal to the number of columns. But in case of assignment problems, the number of rows should be equal to the number of columns. That is why both upper limits are same. I mean, if the upper limit is that, for example, you have a 5 cross 5 matrix, number of rows are 5, number of columns are 5, then you have to write summation I is equal to 1 to 5, summation j is equal to 1 to 5. Cij, Xij, where the matrix order is 5 cross 5, which is required in assignment problems. The assignment problem always says it will be balanced only when the number of rows and number of columns are equal. Then coming to subjected to constraint, in transportation problem we used to write summation I is equal to 1 to n, xi is equal to bj. We are using a, I, bj, but here no need. Here it is something like that. When summation I is equal to 1 to n, taking this side you have to write some for j is equal to 1 to n, with both upper limit is n. But here the total summation in the form of row always should be equal to 1. When you have taken the limit is I is equal to 1 to n, remember here you have to write j is equal to 1 to n. Similarly, when you are writing summation j is equal to 1 to xi is equal to 1, then here you have to write I is equal to 1 to n. And the final non-negative constant says whatever the variable you have taken, whether you talk about x1, for example, xi is I is equal to 1, j is equal to 2, so x1, let you have taken I is equal to 2, j is equal to 3, 2, 3, next to 3. So whatever the value of the variable you take at any position of the matrix, always the value should be either 0, 1. It should not come in other forms. Because this method says always you have to assign 0 assignment. While coming to routing problems, it will be different. With 0 assignment creating problems, you are able to find the root, you will go for 1, next higher value, the next higher value, and we'll discuss later on. But at least timing is remember, always the non-negative constraint means what? It should be either positive or 0. When you constraint 0 and 1, also it is positive and 0. 0 is 0 and 1 is more than 0. It is not negating in rules. But here you have to remember, always in assignment problems, the value of the variable at any position of the matrix will be either 0 or in the 1. Now what are the steps you have to follow while solving the AP? First you have to check whether AP is balanced or not. How to know? As I said, number of rows, number of columns you have to check. If the number of rows are 3, let number of rows are 3, 1, 2, 3, columns should be 3. Then what things are there inside the matrix doesn't matter. Any variable, any value of the any elementary values possible. No need to have any problems or no problems at all. But the moment you feel that the matrix short is 2 cross 4, something like that, or 3 cross 4, then it is called unbalanced assignment problems. So first you have to make it a balance. How? Now you felt that row side there is a deficit, so one extra row you have to add, which is called dummy row. But the value will be, dummy row means the value will be 0, 0. Now it is balanced. But here all the values are non-zero. Maybe 0 exists, but dummy says always whether you take a row or a column, the value should be 0. Dummy means what? It is adjustment. Because once you take this and your problem is solved, then it has no use. Whatever the dummy concept written, it is only for adjustment. You talk about transportation problem, you talk about assignment problems, you talk about in project management, you are using dummy activity. There's a concept dummy activities. The activity you are taking to have a complete figure of the networks, complete of a network, but it has no use. Once it is done, network over, then it is, just throw it, no use of this. But if you want to solve it, first you have to make complete. In assignment problems, once you have to go to the solution steps, the first step is not a balance, the first make it a balance. Unless you are making it a balance, you cannot go to the next step. The same thing I have written, if not a balance, add a dummy row or dummy column to the given matrix to make it balanced. Because one side will be deficit, either row side will be deficit or a column side will be deficit. Both sides won't be deficit. Let the 2 cross 3 means what? You have to make it 3 cross 3. 4 cross 2 means what? So you cannot decrease it. Let there is a matrix 4 cross 2. 1, 2, 3, 4. The rows are 4, columns are 2. So here also possible, but it is an unbalanced AP. How to make it balance? Now you have to add extra 2 column. And all this column value is 0. This is called what? 2 dummy column we are taking. That is why I have written there, if not a balance, add dummy row or dummy rows. Because wherever you require more than 1 row, you can take, that is called rows. Wherever you require 1 column or more than 1 column, that is columns written, columns also written. To make it a balance, to make it square. Because this is a matrix where you can say it is a square matrix. Which one? This one. This is square matrix. But in the initial position of this matrix was not a square matrix. But later on you have made it square. Now it is 4 cross 4. They don't say earlier it was in 3 cross 4. But after adding this dummy row, now it become 4 cross 4. So this is all about how to make it balanced. The next step is either you have to go for row minimization or you have to go for column minimations. So then you have written there, if you are going for row minimization, then the next step will be you have to go for a column minimations. But you have taken column minimization fast, the next step will be row minimization, but both has to be followed. Excuse me. So there is steps like the Hungarian says, there is steps there, any material you change, whatever the steps are written always, either you go for row minimization, then you go for directly column minimations. If you are going for column minimations fast, then the next step will be row minimations. Both has to be followed. Then you have to draw some lines. Some line you have to draw. Why this line? Now the line will be covering all the zeros. The target will be to cover the zeros, not to other values. But while covering the zeros by the line, while cutting through row wise or column wise, if other element are caught, that is no wrong. But zero is the main focus. And finally, the number of lines should be equal with the order of matrix. When you are drawing the line to cover all the zeros, that line should be equal with order of the matrix. Let the order of matrix 3 cross 3, so you should get 3 line. But how to get 3 line? Now you have to maintain a sequence. Wherever there is a maximum 0, that you caught fast. Then you come to minimum. Then when you have written, draw the number of line with a sequence of covering maximum 0 to minimum zeros. You shouldn't go from minimum to maximum, maximum to minimum. Let the 3 cross 3 matrix, 3 cross 3 matrix, this one. There is a 3 cross 3 matrix. So always you be expecting in which row or which column having 3 number of zeros. That row or column should cut fast. Then if you are not getting 3 0, then come to 2 0, then come to 1 0. But all the 0 has to be covered. And we'll see by example how the problem can be solved. Finally, you have to assign the zeros. How? Like this way. It should be set by square. This is called assignment of zeros. Zero assignment. Actually, assignment nothing but zero assignment. With the rule that each row and each column should carry 1 assigned zeros. So what is the last objective, last target? Now you may get the number of line equal to order of the matrix, but the moment if you are not getting each row and each column having 1 assigned 0 values, then it shows while drawing the line you have made a mistake. That again you have to rectify. You have to go to the previous step and you have to find out what is the mistake you have done. Unless you identifying it, the table will continue. But the main target always will be there, the last step, remember it always, this one, the vital. Assign 0 with the rule that each row and each column should contain 1 assigned 0 values. For example, this one, let you are getting assigned 0 1 here. Let you are getting 1 assigned 0 here. Let you are getting 1 assigned 0 here. So what happened here? Now first row 1 assigned 0, second row 1 assigned 0, third row 1 assignment zeros, first column 1, second column 1, third column 1. And that is our target. Each row and each column should have 1 assigned 0 values. Now coming to example, you can understand. A job has 4 men available for work, and I told you always the relation should be 1 and 1. There are 4 jobs, there should be 4 employees. There are 4 machines, there should be 4 jobs. It is 4, another side is 5, so first you make it 5. Which side is less, that has to be more by adding 1 or 2 column or 1 or 2 rows as by requirements. Here in this case, a job solve, because you have a different types of production process. One is job solve, batch solve, mass, and then continuous production process. So job solve talks about job solve, where job means frequently we are not giving it. Once the order comes, then we are starting the production of this job. The job serve has 4 men available for work. This side is 4 men. Let me show. This is four men ABCD, but there are four jobs 1, 2, 3, 4. Then you have to assign all these jobs to all the men in such a manner where one job will be given to one person or one man, second job to another man, third to another, but not necessary. One should be assigned to A, two should be assigned to B, three should be assigned to C, four should be assigned to D, not necessary. But if happens, it well and good. So only one man can work on any one job. I have told you always the relationship should be one. The cost of assigning each man to his job is given in the table below. So always the elements which are given inside the matrix show in the form of what? Elementary values. Here it is clearly written the cost of assigning each man to his job. For example, this one. When you assign job 1 to person A, then 20 rupees you are spending. The total cost you are spending is 20 rupees. When the job 2 assigned to man A, he can do it, but the expense will be 25 rupees. So here what happened you got? Now there is always linked to the job with man. Any value can be behave in this way. For example, 21. 21 is 21 rupees late. Means what? When the third job you are assigning to man C, then the expenditure will be 21 rupees. He is taking 21 rupees to cover. 17 means what? When the fourth job we are assigning to man B, expenditure or he is taking whatever, the expenditure in his head is rupees 17. Like this, all the values are given. That's good. Like we consider 23, it says, or for example 24 or whatever, like for example 17. 17 means when the job 2 assigned to man C, the expense will be rupees 17. It can be $17, it can be any currency, but as is clearly written the cost of assigning each job, so the values are in the form of cost. But sometimes the value may be in the form of hour. Later assigning different jobs to different people, but they are taking certain duration to cover it. Here sometimes it can be in the form of hours, right? But here, let me write, you can understand it. Here is again the form of rupees. I mean 20 rupees, 25 rupees, 22 rupees, 28 rupees like this, 15, 18, 23, 70 like this. But sometimes it can be in the form of hours. As by the questions, like 20 hours, 25 hours, 22 hours. I mean, sometimes you are giving or you are assigning job 1 to person A, is taking 20 hours to complete. When you assign job 2, to person A, taking 24 hours, 5 hours to complete. So sometimes you can given in the form of time, in the form of expenditure like this. And in both the cases, always you are thinking about a minimum. This is one of the example which talks about a minimization form. I told you there are 3 varieties. One is minimization form, one is maximization, one is constraint form. Constraint, not constant, this is constraint, means restriction. 3 varieties. And clearly it is a minimization form because it's a cost given. Now coming to solution, first of all, we have to see whether it is a balance or not. Check it is a balance or not, it is balanced. So why? Because the matrix already is 4 plus 4. 4 rows, 4 columns. So clearly it is a balanced. Sorry, mistake. Not TP, this is MP. Assignment problems. So clearly, this is a balanced APY because the number of jobs are 4, number of men are 4, 4 plus matrix should be balanced. I told you in the previous steps, when it is balanced, what to do? You have to go for finding the row minimization, then column minimization, or column minimization, then row minimization. Like this, but both has to be followed. And let us see. It has gone for first. row minimizations. Like first row, let me show you can understand it. First row values are 20, 25, 22, 28. Which one minimum? That 20 is minimum. If 20 is minimum, 20 has to be subtracted from all the elements of the first row. So 20 minus 20 is 0. 25 minus 20 is 5. 22 minus 20 is 2. 28 minus 20 is 8. I mean it is 0, 5, 2, 8. Check. 0, 5, 2, 8. 0, 5, 2, 8. Similarly, second row, you have to look each row wise because the table name is row minimization. This table name is what? Try to understand it. This table is called row minimization. The question may come to your mind, why it is row minimization? I mean, why are you talking minimization? Because cost is given. Similarly, second row, the minimum is 15. The 15 has to be subtracted from all the element of the second row. 15 minus 15 is 0, then 3, then 8, then 2. So 0, 3, 8, 2. Check. 0, 3, 8, 2. Similarly, you have taken third row. Similarly, you have taken fourth row. Now, this way, this table has been done. Now, coming to the next one, the next table is called, I'm writing here, column minimization. Column minimization. The question always comes whether you should go for row minimization first, then column minimization, or column minimization first, then row minimization. So originally suggested you go anyways, either row, then column, or column, then row. Both is okay. But when you have taken row, the second row cannot be taken. You have to go for forcefully two column minimization. What the Hungarian says, the step says either row then column or column then row. Now from the latest matrix, row minimization matrix, you have to go for, from this matrix you have to find out then column minimization. Column minimizations. Check in first column. First column minimum is 0. If the minimum is 0, if the 0 you are subtracting from this column, so the value remains same. 0 minus 0, 0, 0 minus 0, 0, 2, 2 minus 0, 0, 2 minus 0, 2. Now coming to second column. Don't be confused, this is our matrix. In first column, 0, minimum is 0. The 0 if you subtract from each element of this first column, the remains same, no change. Second column, minimum is 0. Again, if you subtract from this column, no change happens, so it is copied 5320. I mean 5300. Similarly, in third column, the minimum is 1, so 1 has to be subtracted from each element of the third column. So 2 minus 1 is 1, 8 minus 1 is 7, then 4 minus 1 is 3, 1 minus 1, 0. Check. These are the values. Now coming to fourth column, the minimum is 1, so 1 if you subtract, it gives 7, 1, 6, 0. 7, 1, 6, 0. Now you have got row minimization, then column minimization. Always it has to be followed. Either you go for column minimization, then row minimization, or first row minimization, then column minimization. Then you have to go for drawing the line. Let me draw, you can understand it. Once you get like this matrix, check, I'm talking about this matrix. In this matrix, check which row or which column contain highest number of zeros. Now first row having 1 0, second row 1 0, third row 1 0, fourth row 3 0. The highest number of 0 is which line? Now this is 0, 0, 0. This is 0, and this two are 0, 0. The total number of 0 exists in this matrix. So you put out highest zero present in this row. That you caught first on line number 1. Once any zero cancel, that cannot be considered further. Then you have to check which row or which column having highest number of zeros. Then I hope or you can understand this column number 1 will come first. I mean after this line number 2. Then after again you have to check where is 2 0 exists. Perhaps there is no 0 exists, only single 0 exists, because any 0 cancelled once by the line that never considered further either for any row or for any columns. So when you have a single zeros, either you can cut it row wise or you can cut it column wise. For example, this is line 3. But you are expecting how many lines? You are expecting 4 lines. Why? Now the matrix short is 4 cross 4. 4 cross 4. But you got 3 lines. If you got 3 lines, check the solution is coming like this. This is line number 1. We have taken. This is line number 2. We have taken. And this is line number 3 we have taken. But how to assign it? Always either follow again, either row wise or column wise. Just check the previous slide, I can show you. This is the matrix, and you got 3, 4 rows, 4 column. So assignment not possible. The number of lines are 3, but you should get 4. Once you get 4, the solution will come out. But it doesn't mean like that as number of line can be drawn in any ways. Like if you say line is 1 0 is there, I can draw 1 line, I can draw 2nd line, I can draw 3rd line, I can draw 4th line. That way you cannot do. The method always says you have to draw the line where the number of zeros are maximum first. Because clearly in this matrix, the number of zeros are 3, which is maximum at the row number 4. That is why the line 1 you have taken. Here after 3 0, you got 2 0, which present in line column number 1, that is line 2. After this, there is single zero exists, either you can cut by row wise or you can cut by column wise. Then you have to go for assignment, either row wise or column wise. Let us consider row wise. Row wise, if you consider, this is 1 0 you got, right? Once any 0 you have taken, the corresponding 0 present in other column row will be cancelled. Column side this 0 out, row side there is no 0. Now here you have start. Why? Because the method says assign 0 with the rule that each row and each column should carry 1 assigned zeros. See, in this matrix already we got 1 assigned zeros, but second row is vacant. This 0 is out. Why out? Because this 0 was coming for the corresponding of these zeros, corresponding column. So in any 0 if you are assigning, that corresponding row column other 0 will be cancelled. That is why this 0 cancel, and there is no 0 left either in this column or in this row. But anyways, the second row is vacant. But the method says each row and each column should have a 1 assigned 0 or row column एक 0 चाहिए. You need 1 zeros. That is why it is rejected. Also, you have checked by the lines. So how many lines you require? You require 4 lines. Let us verify this. Here, you check. You got 1 0 in this row number 1. Here you got 1 assigned 0. This will assign zeros. Second row blank. Third row 1 zeros. Fourth row 1 zeros. But the method says each row and each column should have 1 assigned zeros. Here the 1 0, but there is no 0 in this row. Column side, if you also check, first column having 1 assigned zeros, second column having 1 assigned zeros, third column having 1 assigned zeros, or fourth column blank. And that should not. If this situation arises, then what to do? Now you have to find out. Let me show you can understand it. In this case, again the matrix you have to draw. And find out some element which are not covered by the lines. Check the previous one, I can understand it. When I have taken this line, but the elements were like this, it was 5, 1, 7, 3, 7, 1, and it was like 3 6, and this one like 2, this one is 2 1. Now these are some of the elements like 5 1, just a minute, 5 1 7 3 7 1 are not covered by any lines. So what will do, the Hungarian says the element which are not covered by the lines, find out. And among this, which one minimum that you have to find out? The minimum is 1, but you have a double 1. So any one can be considered. And this one will be subtracted from the uncovered by elements and will be added where two lines cross each other. So here two lines cross each other. So this will be 2 plus 1 is 3. Here also two lines cross each other. So you have to add 2 plus 1 is 3. But when there is single line cut to any element, there will be no change. But whereas this minimum value will be subtracted from the uncovered values. I mean, this 5 value in the new table will be 5 minus 1 is 4, 1 minus 1 0, 7 minus 1 is 6, 3 minus 1 2, 7 minus 1 is 6, 1 minus 1 0. Let us check it. You can answer. Check this the elements. 0 5 1 7. 0 5 1 7, 0 3 7 1. But after drawing line, you got 3 lines, and these are the uncovered elements. These are the uncovered elements. This 1 7 3 5 1 7. Now among these, which one minimum? 1 is minimum. Same thing written. You can check also sometimes by theory. What I am saying by practical is same thing ever. Develop a new revised table, examine those elements that are not covered by the lines. Which are not covered by the lines? Now 5 1 7 3 7 1. By subtracting 1, why you are subtracting 1? Now among this value, which one minimum? 1 is minimum. So 1 has to be subtracted from all the elements of the uncovered values. I mean 5 minus 1 will be 4. See the next table. 5 minus 1 is 4. It was 1, 1 minus 1 0, 7 minus 1 6, check. 7 minus 1 6. 3 minus 1 2. The 2 6 0, check. 2 6 zeros. And apart from that, wherever two lines cross each other, I mean this position, two lines cross each other, this line, two positions cross each other. In that case, this minimum value will be added. When it was 2, now it will be 2 plus 1 is 3. Here also it was 2, the 2 plus 1 is 3. 1 means what? The minimum value you got from the uncovered values. Check, same 3 now. And this is 3, this is also 3. Now again you have to start the same thing. Go to step 3 and repeat the same procedure until you arrive at an optimum assignment or optimal assignment. Means what? The moment you get each column is having one assigned zeros, then your solution is over. But if you are getting the number of line is not equal to our matrix with a sequence of covering maximum 0 pass, then minimum, then the process will continue unless you get equal number of lines with our matrix. But the rule has to be followed. You have to maintain the sequence, not like this randomly you can draw the lines. Execute. Now once you got this matrix, then the same thing you have to do. First you have to draw the lines. You got 4 plus 4. Let me show how you can do it. And easily can understand. Now you got 0 here, you got 4 here, you got 0 here, you got 6 here, then 0 2 6 0, 0 2 6 0, 3 0 3 6, 3 0 3 6, 3 triple 0. Now check which row or which column contain having highest number of zeros. Now the last row again having highest number of zeros, so cut by line 1. What next? Here either in first column having 2 zeros or second column having also 2 zeros, second row also having 2 zeros, but this is 1 zeros. Tell me which one should take. Because the objective is minimum line should be covered. talk minimum line, this is line number 2. This should be line number 3 because 2 0 exists. The single zero exists, either you can count by row wise or you can count by column wise. Row you have taken, so go for line by column wise. Now how many lines you got? Now you got 4 lines. 4 lines means you have got by the rules. You have not defined rules. And the order of the matrix is 4, you got also 4 lines. It shows the optimal solution exists. I mean, you can have the solutions. When you're expecting you can have the solution, then directly you have to go for another matrix like this matrix what it is given, and only the 0 part you take, other part you don't take. I mean this is 0 4 0 6 0 2 6 0 0 2 6 0 3 0 3 6 this is 3 0 0 0. I have to go for assignment. Now first having how many zeros, because we always prefer to go by row wise or column wise, but keeping in mind that each row and each column should have one assigned zero values. When the hints already come to you that the number of lines is equal to order of matrix, it shows the optimal solution should come. Let us verify. Let's check. First having this zero and these zeros. If I take this zero, no wrong. If I take this zero, there is no wrong because this zero may cancel, whereas there is second zero existing in this row. Let us take this one assignment. The corresponding column other zero cancel. Corresponding row other zero will also cancel. Now coming to second row, there is single zero exists, directly you can assign it. Whereas corresponding column 1 0 cancel, row wise no zero exists because already 0 is cancel. Now coming to third, this you take because only single zero exists. If you take this one, this zero will be out, corresponding column. There is no zero exists in this row. Finally, we have a single zero exists in fourth row. Now check whether it is satisfying your result or not. Because your method says each row and each column should have one assigned zeros, what I have written. Assigned zeros with the rule that each row and each column should have one assigned zeros. Now you check. First row having one assigned zeros, second row having one assigned zeros, third row having one assigned, fourth row having one assigned zeros. Similarly, first column having one assigned zeros, second column having one assigned zeros, third column having one assigned zeros, fourth column having one assigned zeros. I mean, solution over. Now once you get this, the next step is you have to find out the optimal assignment. You have to write the optimal assignment is. The optimal assignment is, you have to write, because this side is what? A, B, C, D. What is this? Main, this is job. So for main A, which job will be given? The A corresponding value is here. This is what? First job. So A will be given to, first job will be given to person A. Then come to B. Now B linked with this box. The fourth job, the fourth job will be assigned to person B. Now coming to C, under C you have this square box, this assigned zeros, corresponding value is 2. So job 2 will be assigned to person C, man C. Now this shows job 3 has to be assigned to person D. So D tends to 3. Now what is the total cost you got? Now all this cost we added, which is present at this position. Let me show you can understand it. This position plus this position, this position plus this position plus this all have to be added. But where? From the first values, from the original table. Now this is original table. So you got 20, let me show. 1 4 2 3, 1 4 2 3. And this one 1 4 2 3, this one. Second or fourth questions means this one 1 4 2 3. Sorry, mistake. This one. One, 4, 2, 3 means this one. 4 means this one. 2, 3. Now all these 4 has to be added. So you got Z is equal to 20 plus 17 plus 17 plus 24, by which you got 78 rupees. 78 rupees. The Z value got 70 rupees, and it has to be specified. Where x11 is, I mean, you got the value of the variable at x11 position, you got at x24 position, you got at x32 positions, and you got at x33 positions. So this is all about minimization form. Means what? We are assigning the job 1 to person A, 4th job to person B, 2nd job to person C, 3rd job to person D. Now coming to this example, similar this exercise you can do, where it is given a tourist car rental firm has 1 car in each of the 5 depots. We have 5 depots and we have a 5 cities. The distance in kilometer between the depot and cities are given in the form of maybe kilometers. This kilometers is given. Like from depot 1, for example, if you consider this one, because 140, what does it mean? The distance between depot 1 to first city, the distance is 140 kilometers. City 2 to depot 1, 15 kilometers. Like this, all these values are given. So what to do? Your objective is how should the car be assigned to the customers so as to minimize the total distance covered. How to cover all these depots, right? So you have to assign, because when you talk about minimize the total distance, obviously it is a minimization form. So first of all, you have to check it is a balanced. If balanced, then you have to go for row minimization. Then you have to go for column, like reverse solutions, column minimizations. Then you have to go for drawing the lines. The number of lines, if you're not equal, then you're going to go for changing, find the minimum value from the uncovered elements. Then that has to be subtracted from the uncovered values and will be added to the, like this what I have done. These are the uncovered values. From the uncovered you got a minimum is 1, then 1 you are subtracting from the uncovered values and you have added in the cross position, because previously it was 2 2 and 2 plus 1 become 3 3 you have written in this matrix. Then again you draw the lines. Once you get equal like this, then the solution you can find out in this way. So this is one of the exercise you can do in home. Now coming to another varieties, that is called unbalanced assignment problems. This assignment problem you got, but how to know it is unbalanced? Just a minute, all of you. Yeah, it is an unbalanced assignment problem. Why? Because you have a 5 job and we have 6 operators. Then how to assign? The objective is to assign one operator to one job, or you have to assign one job to one operator, second job to another operator, third to another, fourth to another. The relationship should be one on one. It cannot be one job to more than one operators, or else one operator should not take at a time to more than one jobs. Either he has to take either one job or 2 or 3 or 4 or 5 or double jobs. The first operator is not a square matrix. Why? Because the matrix order is here 6 cross 5. 6 rows. There is 6 rows, row 1, row 2, row 3, row 4, row 5, 6. Then column is 5. So value cannot be minimized. So wherever side is the value is 5, we make it 6. How? You have to take an extra job that is called dummy job. Solution check how it has taken. Dummy means all the entries will be zeros. So the extra part it has taken extra part to make it square, because earlier it was 6 rows but having 5 column. The moment you are adding this column, that becomes 6. Then the same procedure has to adapt like when we talk about minimization, minimizing the total time. So clearly it is a minimization form. If minimization form, directly you have to go for row minimization, then column minimizations. Like this you have to proceed and find other steps will be same. Now coming to some more example. Like the personal manager of a company wants to assign Mr. X, Mr. Y, Mr. Z to regional office at Delhi, Mumbai, Calcutta and Madras. The cost of relocation, see, cost given. Suddenly you can understand the shape, I'm showing it, you can understand better. Here it is given cost. Cost means the question is given the form of minimations. So the cost of relocation in rupees of 3 officers at the 4 regional offices. So the officers are 3, but regional offices are in different locations, no? On Delhi, Mumbai, Calcutta and Madras. So here it is clearly unbalanced. Because you have a 4 cities, but the officers who are going to assign all these cities, they are 3. So first of all, you have to make a dummy officers to make it a balance. Because unless you are making it adjusted by dummy, you cannot solve it. So that is why in solution it is written, officers are Mr. X, Y, Z, then dummy officers. Dummy means what? When the dummy you are taking the form for row, all these values will be zeros. And as like the columns are 4, I mean the data are given for Delhi city, Bombay, Calcutta, Madras, and same things copied here. Only the extra dummy rows you have taken 0 zeros. And the process remains same. What to do? First you have to go for, once you have made it balanced, because now it is balanced. After adding these dummy zeros, the next step you have to go for row minimizations or column minimizations. Both are right. The next step will be, once you have done row minimization, next you are forced to do column minimization. But if you have taken column minimization first, the next step will be row minimizations. Then you have to go for drawing the lines. And the number of lines should be equal with order of matrix. If not happens, what the procedure I have told you, find out the minimum values. Again, you subtract from the uncovered elements and add where 2 lines cross each other. Once you get it, the number of lines in order of matrix, then you go for, I mean, it shows the optimal solution exists like the previous level. Once it's equal, you have to go for assigning the zeros. Keeping in mind that each row and each column should have a 1 assigned 0 values. But there is another case like maximization form of a P and minimization form of a P. Sorry, constant form of a P. So what is maximization form of P? Let in this question, if you talk about this question clearly given in minimization form. Let you think it is given maximization form where it is asking the profit generated by the different officers, the values are given. Let 16,000 rupees, 22,000 rupees, or sometimes you can expect the form of lakh rupees. Sorry, it is given the form of rupees, so behavior is rupees, 16,000, 22,000, 24,000, 20,000 like this. So if profit given, though it is clearly mentioned cost in the form of rupees, cost means always minimization form. But if profit given, you have to think about maximization form. And if it is maximization form, the process remains same. First you add a dummy row, then one extra matrix you have to do, that is called opportunity matrix. What is that? Now first you have to draw a matrix. The matrix name is opportunity matrix. after making balanced, what steps you have to do? Like, let me draw, you can understand. Now find out among the whole value which one is maximum. Here the maximum is 32,000. Now from this 32,000, all the value will be subtracted. I mean, this will be 32,000 minus 16,000 becomes 16,000. Like this, all the value will be subtracted from 32,000 only. Why? Because 32,000 is the highest values. Whatever the result you got, the next step is you have to follow row minimations, again column minimations, then same procedure, drawing the lines, assigning the zeros, and once you get the assignment, again you have to follow the original matrix, and from original matrix the value you add, whatever result comes, that is your answer. So this is all about your minimization form and maximization form. And next class we'll see some other portion of the LPPs. Thank you all.